Alright, we're going to do section 4.2. You're going to need have your textbooks open to page 224. And you're just going to need pens and pencils for today, maybe a highlighter. We're going to start talking about writing equations in slope-intercept form. And from the 4.1 notes, we know that slope-intercept form is y equals mx plus b, where m is our slope and b is our y-intercept. So slope, remember, is rise over run, or the change in y over the change in x. Y-intercept is where it crosses the y-axis, or we would have the ordered pair 0 and then a y value. Remember that y-intercepts don't go left and right, they only go up and down on the y-axis. So to start writing these equations, they might give us like two ordered pairs and say, here are 2 points that fall on the line, write the equation in slope-intercept form. We know how to find slope from two ordered pairs, and from that we can use the equation y equals mx plus b to find b, and I'm going to show you how to do that. To start doing this, to write the equation in slope-intercept form, you have 3 steps. The first thing you have to do is find the y-intercept, then you find the slope, and then you just write the equation in slope-intercept form because you know m and b. Something to keep in mind is that steps 1 and 2 are interchangeable. Sometimes we have to find the slope in order to find the y-intercept. I'm going to show you an example of both today. So the first example says to write the equation of the line that passes through the point 2, 1 with a slope of 3. We got lucky. This example said m is 3. They give us the slope. But now I have to find the y-intercept. In order to do that, I'm going to use this ordered pair. Now remember, ordered pairs are written in the form x, y. So they give us an x value and they give us a y value that if I were to plug into the equation, they would make it true because they fall on that line. They also give us the slope. So I'm going to take y equals mx plus b, and I'm going to plug these x and y values in and this m value in and solve for b. So I know from this ordered pair y equals 1. M is 3, x is 2, and I still don't know b. That's what I'm looking for. But now b is my only variable, and I know how to solve using algebra to find out what b is. I'm going to say 1 equals 6 plus b. Now to get b by itself, I have to subtract it because it's positive and it's being added. So I have 1 minus 6 gives me negative 5 equals b. So now I know my y-intercept. Okay, let's go look at our steps. Do I know my y-intercept? Yes, it's negative 5. Do I know my slope? Yes, it's 3. Now the last thing I have to do is write it in slope-intercept form, which is y equals mx plus b. So I'm going to start plugging things in. Now, when I wrote this up here, I had to put 1 and 2 in for my x and y. That's just one specific point that makes the equation true. But we're trying to write a really broad, general equation that makes all the points on the line work for this equation. So I still have to write it as y equals, then I use my m, which is 3, x, plus a negative 5. And remember from last lesson, we were able to write this as y equals 3x minus 5. Adding a negative is the same thing as just subtraction. So this is the equation of the line in slope-intercept form. That can be kind of tricky. I would suggest pausing the video and checking out some of your homework questions to see if you're able to do this on your own. If not, put a star by them so when you come to class, you're able to ask me those questions. Alright, next page. Write an equation of the line that passes through the points 3, 1 and 2, 4. This is an example where we have to do step 2 first, where we have to find the slope first, and then use it to find the y-intercept. So to do this, I'm going to find my slope using those 2 points, and I know how to do that. Remember, it's y1 or y2 minus y1 over x2 minus x1. So 4 minus 1 over 2 minus 3. And I get 3 over negative 1. I'm just going to rewrite this as negative 3. We're not graphing it, so we can take it out of fraction form for right now. So remember that 3 divided by negative 1 gives me a negative 3. So now I have my m, and I'm going to go back, and now I have to find my y-intercept. Remember that we just had 1 point and the slope last time? Now we have 2 points. You can choose whichever one you want. Both of them lie on that line, so both of them will give you the same value. I'm going to do both of them to show you that they give you the same value. So we know that we have y equals mx plus b. I'm going to start with this one, and I'm going to say 1 equals negative 3 times 3 plus b. I got the 1 from this y value. Negative 3 is my slope. This 3 is my x value for the point, and then plus b because I'm still looking for that y-intercept. So I'm going to start solving. 1 equals negative 9 plus b. I'm going to add 9 to both sides to solve. I'm adding it because it's negative. So 10 equals b. So let's try the other point. Maybe you like 2, 4 better than 3, 1. Let's see if we get the same thing. Remember, I have y equals mx plus b. My y value is 4 equals, my slope is negative 3, my x value is 2 plus b. So I have 4 equals negative 6 plus b. I add 6 to both sides because it's negative, and I get 10 equals b. So do you see how it doesn't matter if I choose this point or this point, as long as I'm using this slope and it falls on the line, I'm going to get the same y-intercept, which is a good thing. So I'm just going to write the general equation now. Y equals, my m is negative 3, x plus 10, because 10 was my b. That's the equation of the line. When you do this on your homework, you only need to do 1 point. You don't need to show that they both give us the same b value. Just choose one and solve for b using 1 point. Alright, here's one more example that's just like that one. I'm going to give you about a minute, and then we'll come back together and work on it. Okay, if you need more time, pause the video and then come back and watch the rest. So this has to write an equation of the line that passes through the points negative 4, negative 2, and negative 5, negative 6. We're going to use the exact same process as the one above it. This time I'm only going to find one of the b's instead of using both points. So first thing I have to do, find the slope. I'm going to say, this is my second point and this is my first point. Negative 6 minus a negative 2 over negative 5 minus a negative 4. Remember that subtracting a negative is the same thing as adding a positive. Same thing in the denominator. So negative 6 plus 2 gives me negative 4 over negative 5 plus 4 gives me negative 1. Now, a negative divided by a negative gives me a positive, and 4 divided by 1 just gives me 4. So I'm going to get positive 4 for my slope. Okay? Second thing I have to do, find my y-intercept. Okay, I'm going to set up my equation, y equals mx plus b. I'm going to choose this ordered pair. If you want to choose the other one, that's just fine. Remember that it doesn't matter which one you choose, you will get the same b value. So my y is negative 2 equals, I know my slope is 4, times x, which is negative 4, plus b. So now I have negative 2 equals negative 16 plus b. Now I have to solve to get b by itself, so I'm going to add 16 to both sides. I'm adding it because it's negative, and it cancels over here. Negative 2 plus a positive 16 gives me positive 14 equals b. So now I know my y-intercept and I know my slope. Slope-intercept form is written as y equals mx plus b. So we're going to write the general equation, which is y equals 4x plus 14. Okay, turn to the next page. You should be looking on page 226 of your textbooks because we're going to do the real world example, which is found in your textbook. The problem reads, the table shows the average fares for domestic flights in certain years. Write an equation that could be used to predict airfares if fares continue to increase at this rate. Basically that's saying I'm looking from year to year, and each year the price of flying increases by a certain amount for each ticket. So we know that from here to here it changes 1 year. Same thing from here to here, same thing from here to here. Now the cost from 2004 to 2005 goes up $12. From 2005 to 2006, it also goes up $12. Same thing for 2006 to 2007. So we can see that it has a constant rate of change in that. Well, we're going to call this our x value. And it has a constant rate of change on the y value. So yes, this is linear. We can write a linear equation for it in slope-intercept form. So we're going to say the slope or rate of change is the change in y over the change in x. The change in x, well, let's start with the change in y. The change in y is 12 over the change in x, which is 1. Slope is just 12. Easy. We found our first value. Second thing I have to do, find the y-intercept. Now, if I look at this table, I have 4 sets of ordered pairs: 2004, 354, 2005, 366, 2006, 378, 2007, 390. I'm going to choose any of them. I'm just going to go with the first one, 2004, 354. It would not matter what you chose because it's a line, you would get the same b value. So remember, I have y equals mx plus b. I know my m, and I have an x value and a y value. I need to find b. So I'm going to plug in 354 equals m, which is 12, times x, which is 2004, plus b. Now, something to keep in mind, I'm doing this a little bit different from the textbook. They decided to go with years since 2000. So instead of putting 2004, they just put 4. That will give you a different b value. We're going to stick with this plan, and I'm going to show you the difference at the end. So 12 times 2004 gives me 24,048. I'm going to subtract that amount from both sides. I'm subtracting because it's positive. And I get negative 23,694 equals b. Go take a look at the answer that they get in the textbook. They get 306. I want you to take 2,000 minus 23,694. That didn't work. Let's see. We would write our equation as y equals 12x minus 23,694. The difference is you're accounting for the entire year. This kind of gets hard to read because you're like, 23,694, that number doesn't make a whole lot of sense when we're talking about changing 1 year at a time. So let's go ahead and try what the book did. They said instead of using these points, I'm just going to use 354 because this is the 4th year after 2000. So let's see what they got. We still have the slope of 12 because it's still changing 12 in between each one and 1 in between each of these. So I'm going to say 354 equals 12 times 4 plus b. 354 equals 48 plus b. Subtract 48 from both sides. We're subtracting because it's positive. And so now I get 306 equals b. That's what the book got. So when we're talking about cost for each year, they're saying when it's at exactly 2000, we get $306. This makes more sense than this does. So when you're talking about years, I want you to choose a year since 2000 instead of just the actual year. So our equation reads y equals 12x plus 306. To talk about the real world meaning of that equation, they're saying that to find the cost of what it might be in a certain year from now, I'm going to take the number of years since 2000, so if we're talking about this year, 2013, you would say 13 times 12, and then plus that initial $306 that it cost in 2000 is going to give me what I can predict that my air ticket's going to cost. So we're talking about a prediction in this equation, right? An equation that could be used to predict. The vocabulary word that is associated with prediction and linear equations is called linear extrapolation. And basically you use your history points, so points that you know are true. So in our example it was 2004 through 2007. Those years have already happened. So we can use them to write an equation to predict what might happen in a couple of years. So we're going to say using linear equations to predict about to predict values that are beyond the range of the data. Basically that means to predict what might happen in the future or predict trends for the future. Here's an example. Now, on page 226, example 4, we're going to use the example 3, so what we just found, this one, 12x plus 306, to predict the cost of airfares in 2010. So the first thing I need to do is write down my equation from the previous page. Y equals 12x plus 306. Okay? So they're saying predict this airfare for 2010. Now 2010 has already come and gone for us, but it hadn't when they wrote this textbook. So we're going to pretend that that's in the future for us. First thing we have to do is find an x value to plug in. Remember when we were writing our ordered pairs on the previous page, we were writing the years since 2000 as our x value, and then we were getting a cost as our y value. Let's take a look at the table. Years are in the x column, cost is in the y column. So I know a year, but I'm looking for the cost. So I don't know y, but I do know an x value. They're saying 2010. So how many years from 2000 to 2010? 10 years. That's going to give me my x value, and I'm looking for my y value. So I'm going to say y equals 12 times 10, that comes into x, plus 306. So y equals 120 plus 306. Y equals 426. So they're saying that in the year 2010, a plane ticket is going to cost $426. And that's how we use those lines or those equations of lines to predict future values of things so that you know how much they're going to cost. If you're talking about the stock market or trends in business, Wall Street, anything like that, this would be the way to go for right now. So you have your homework. You should take a look at it. Put a star by any of the questions that you don't understand so that I can answer them in class for you. And good luck.